The talk is going to be aimed at computer security and passkeys, and just the transition we're probably going to be making going from passwords to passkeys over the next many years. When I was putting this together, I was thinking to myself, computer security is very, very important. But although this is a highly technical group, so I think most people will agree that it is very important, but other people may not know why computer security is so important. Computer security is actually crucial because it protects the integrity, confidentiality, and availability of our digital lives, which are getting bigger and bigger as time goes by. So it protects sensitive information, personal data, business secrets, government systems. It safeguards critical infrastructure, government agencies, essential services. And this is what I think is very important. Essential services like power grids and transportation systems and healthcare systems. These computers that we use are embedded in all of these types of systems. And if they get hacked or messed up, those systems will just not be there when we need and expect them to be there. So computer security is extremely important. So computer security, also known as cybersecurity, is the practice of protecting computer systems and networks from digital attacks. Sometimes I say this and I think I'm really preaching to the choir. So a lot of this you'll um, appreciate and not need an explanation. But I have given this presentation to other groups that weren't as well educated as this kind of a group. So computer security involves safeguarding hardware, software, and the data from unauthorized access, use, disclosure, disruption, modification, or destruction. So it's really protecting your information, and it's the information that makes those systems run and stay up and running. So protecting is all about authentication. Computer authentication is the process of verifying that a user, a device, or a system is who or what it claims to be before granting access to that digital resource or information. So it's the digital equivalent of asking for an ID when attempting to enter a secure facility. I think everybody would agree that's a good thing. So how do we prove that we should be given access to a computer resource? Well, what's commonly used today is a username and a password. And for every resource you want to go to or use out on the internet, you need a username and a password for that particular resource or server. So it's the credentials for computer access that you need. So you use a username, and to the computer is just trying to believe this is who you are. You're trying to tell the computer who you are. And it's the password that proves that you should have access to that resource that you're trying to gain access to. So in order to make it even more secure, it's usually recommended that a two-factor authentication is used. So the second factor really proves that you should have access. And two-factor authentication is going to be more used in the future. In fact, to my knowledge, Google is starting to require it on certain accounts. And at one time, I thought they were going to make that universal, but I don't know that there's any actual timeline for that. But I suspect that will become reality in the not too distant future. So using your username and password is similar to accessing a bank safety deposit box. Now we don't do that much anymore because we don't even go to the bank much anymore. But if you do, and if you do have a safe deposit box, you have a bank number, and that bank number is the equivalent of the username. It's a public number. Anybody could walk up and make up the number and say, that's my box. But it's the key that proves that it's yours. So just to go back a little bit to two-factor authentication and what you need to do. The two-factor authentication is a method of confirming a user's claimed identity by using a combination of two different factors. The first one is, of course, the password or PIN or security question that we all use. And the second one is something you have or something you are. So that what you have typically is your smartphone. So if you have two-factor authentication on an account, they will usually try to get something to your smartphone in order to prove that you are the individual you say you are. And then, of course, the something you are could be a fingerprint, a retina scan, a facial recognition, or voice recognition. But it's just that second factor that helps guarantee that you are who you say you are. So passwords have been around for thousands of years. Long before computers existed, they were used in the Roman Empire. They were watchwords that identified friends from enemies. Even as far back as the biblical times, words were used. And the word shibboleth, I think I'm pronouncing that right, correctly, was used because one tribe of people could pronounce the word and another tribe couldn't pronounce the word. So if you came from the tribe that couldn't pronounce the word and you tried to gain access to the other to something owned by the other tribe, you wouldn't be given that access. And passwords were used during Prohibition. In the US, there were always secret words that granted access to speakeasies and some of the good stuff. I've heard stories about that, but it was a little bit before my time. But maybe you've heard stories also. So it's passwords that gain you access to something that you would like to participate in. So we get to the digital world, and digital passwords begin around 1961. The first computer password was created by Fernando Corbato at MIT for their compatible time-sharing system. Each user had their own private password in order to get time on the system. And you can, from that picture there, you can remember, well, maybe you can't remember that far back. Big computers that we were using occupied buildings worth of space rather than the little small amount of desk space that we're using right now. So 61, the first computer password. Shortly thereafter, 62, the first password breach, as you would expect. So the first password breach occurred when a student printed out the system's password file to gain more access time. So password breaches are not new. So then we get to the modern developments. In the 70s through the 90s, passwords use became more complex with the rise of personal computing. And in the 2000s, all the way to today, there's been an explosion of online accounts, and it's led to password fatigue. Is anyone here suffering password fatigue? I'm sure if we did a show of hands, everybody would be raising their hands. So during this time, we've seen the rise of password managers. more use of two-factor authentication, and biometric logins, fingerprints, and facial recognition. So password basics, when we use a password to sign up, and then we use that password that we establish every time we want to log in to use the resource. So if you follow this flow chart from left top to bottom, when you input your password characters, the computer that you're putting those characters into creates a hash value. That hash value is stored, and that's what's used when you then try to log into that resource the next time or the next week or the next month. So when you log in, you type in those keys again, and that computer then calculates the hash value, and it's going to compare that hash value with the stored value that was stored when you set up that account. So what's interesting here is it's the hash value that's stored. It's never your password. So your password is never stored. And that's why if you forget your password and you try to get it from the site, they can't give it to you. They can only give you the ability to reset your password. So it's protected in that it's not stored, although some systems do store passwords. So when this hash value is created, the first question that people will ask is, well, what if there's another collection of characters that could create the same hash value? And that's true, it is possible. The hash value is a one-way mathematical function that transforms any input into a fixed length string of characters. Well, if that was the case, that would be called a collision. And I'm told that a collision could only happen 1 in 2 to the 128th power. That's a very, very large number. 2 to the 40th power is a trillion. This is 2 to the 128th power. I don't think I have enough paper to write out the actual number. So it's a very safe way, and the odds of this happening very low. Anyway, that's what's going on behind the scenes when you set up an account and then use your password to gain access to that account. So how do we manage large numbers of passwords? Well, first of all, you probably create a hierarchical organization. If you don't do it on paper, you do it in your mind where you have your passwords organized. So if you have a great memory, you might store them in memory, your own memory. I don't think you can do that beyond a certain number of passwords. So then we write them down. So you write them down on a scrap of paper, and then you have to maintain that scrap of paper, which is easily lost. So if you don't want to put them in a scrap of paper, you write them down in a book, then you hide them in a book, hide that book. Or you write them down on your left hand, and that was always referred to as the Palm Pilot. I'm sure many of you had Palm Pilots along the way. So how many passwords do we have? Well, we have loads, 10, 20, 50, 100. I have over 350, and I'll bet most of you have some number in that general area. So who hates passwords? I think most of us are suffering password fatigue. So there are password managers, and I think Jim even mentioned that he uses one. I personally don't use one, but there are loads out there. After I've asked people which ones do they use, I found that most of the people I talk to use LastPass as a one, but people use all of these. 1Password, Dashlane was used, KeepPass. I don't know anybody who uses Zoho Vault, and I don't know anyone who uses a sticky password. But they're all out there and good. And if you want to get one, find somebody that uses one and get their advice before you jump in. So how about a passwordless future? So passwords have served us well for a long time, but they have some inherent problems. And many systems are shifting towards this passwordless authentication using biometrics, security keys, and passkeys. So passkeys are different from security keys in that security keys are little devices like the USB stick or a fob. So passkeys work a little differently. Um, I'm not sure how many people have been exposed to passkeys, but they're available and being made available by the bigger companies slowly. So a passkey is an authentic credential based on the FIDO standards that allow users to sign in to apps and websites with the same process that they use to unlock their devices. And that would be biometrics, a PIN or a pattern other than a password. And the FIDO has nothing to do with puppies. It's short for Fast Identity Online. It was established back in 2013 with a mission to eliminate the world's reliance on passwords. It's made up of major players like Microsoft, Apple, Google, and hundreds of more. So there's a big push behind it, but this has been around for 10 years. So it's not easy to make that transition. Hopefully it will be done if it's the right way to go. So passkey use, just as an example, if you want to log into someone with a passkey, you click on sign in with passkeys that you would have available to you. The computer would prompt for the fingerprint or the ID. Then if you're signing into a bank account, the bank would get a signed challenge from your device. The login would be completed with no passwords typed in and no phishing. Um, well, hence there will be no phishing problems. So when you would have a separate passkey for every account that you would want to log into, just like you have a separate password for every account that you want to log in. Although I know a lot of people cheat there, they use the same password, and it makes it a little easier when you're remembering passwords. And when it comes to accounts that aren't that very important, it's not a big deal. But for accounts that are very important, you really should use all of the things that you know to create strong and different passwords. So passkeys employ asymmetric cryptography for authentication. Cryptography is the science of securing information by transforming it into a format that unauthorized parties cannot understand. It's the backbone of digital security used in everything from online banking to encrypted messaging apps, and now it'll be used for authentication. What's the messaging app that's used? The name escapes me right now. I'm sure everybody knows it. I can't think of it right now. Anyway, anything that's encrypted will use one form of cryptography or the other. So just a quick review. The two forms of cryptography are symmetric key encryption and asymmetric key encryption. Symmetric key encryption requires identical keys to be used for encrypting and decrypting. It's fast. It's hundreds of times faster than asymmetric cryptography. However, asymmetric key encryption doesn't require both encryption and decryption to have the same key. Having the same key is a big problem. The government has always had a problem with key management, getting the keys out into the field, and then and the instructions on how to use them. So the use of asymmetric key encryption is now being used to send the key to be used for the symmetric key encryption. So just as an example, well, if you're wondering what a key is, what it looks like, it's just a text file. It may be many, many digits long. This was a private key on the top and a public key on the bottom. So again, it's just a text file of characters. Fortunately, we don't have to memorize any of them. That's what your computer is for. So in symmetric encryption, in order to send a message from Bob to Alice, Bob takes an original document, encrypts it with his secret key, and then sends the encrypted document. The encrypted document is unintelligible to anyone who intercepts it. When Alice gets it, she uses the same secret key and decrypts it and gets back to the original document. That original document is exactly what Bob sent. And now she has the information that he intended to send. That's a great way to do it if you can distribute the secret key. With asymmetric encryption, Bob wants to send a message, hello, Alice. He encrypts it with Alice's public key. Now, a public key can be distributed any which way. Because it's public, there's nothing secret about it. So whoever wants to send a message to Alice can use that public key. So he uses the public key. He generates an encrypted message. It's sent to Alice. It's sent to Alice and anybody who wants to interpret it, intercept it, and try to interpret it. They can only if they have Alice's public key. I'm sorry, Alice's private key. So Alice has the private key and has kept it private. She uses that to decrypt the message, and then she has exactly what Bob sent to her. So what's going on the internet is first asymmetric transfer of information, and that information is a symmetric key. It's slow, but it's very short. And then with that symmetric, rather with that symmetric key, both the client and the server now have the symmetric key, and they can use the encrypted. They can use that to encrypt and decrypt data sent between them. And keep in mind, transfer between you, let's say your phone, and the bank's server is not just data going one direction. It's constant packet sending. So packets are going back and forth, and responses to those packets are going back and forth. So there's a lot of information going in both directions. And if it had to be done using asymmetric, it would be very clumsy and very slow, and you wouldn't be able to get the performance that we do get now with the fast internet. So how do you get set up with a passkey? You have a sign up procedure and you have a login procedure, just like you do with a password. So in order to establish an account, you have to generate two keys. This is done by your device. The public key is stored by the website that you're sending it to, the website you want to get access to in the future. And the private key is kept by your system. It's stored securely on your device. So then in the future, when you want to log into that account, you go and you log in. And when you log in, you request a login. The site sends you a document, and they call it a challenge, and it's encrypted with your public key. Again, the public key is out in the public. So this could be anyone who has your public key. When you get it, you use your private key to sign the challenge, and then you return it to the site, and the site compares it to the original. If it gets a comparison, then you can be logged in. So in chart form, a flow chart, your device sends a request. The site creates a challenge, which is going to be encrypted with the public key used. And it sends that challenge document to your device. Your device receives the challenge, signs it with the private key. Only you have the private key, and that private key is sent back to the site where the comparison is done. And if there is a compare, you get your identity has been proven. If there's no compare, then you don't get access to that resource. So it's all done with this combination of two keys, the private and public keys, and this process. So why are the passkeys safer? Mainly because there are no server-side passwords. So even if the site gets hacked, if there's a breach at that site, your passkey can't be stolen because it's the public passkey, and that's known by anybody who wants to know it in the public. And they're phishing resistant because passkeys only work with the exact site that they were created for. They won't work with a malicious or a lookalike site. So if somebody puts up a lookalike site, any kind of site, the sites that you see a lot of are PayPal sites. With passkeys, you wouldn't be able to sign into those sites. You could only sign in with the site that you originally set up your password, your passkeys for. And the passkeys are the public and the private keys. Okay, so Windows 11 supports passkeys. Does Windows 10 support it? I'm not sure. I've never used it on that. I didn't really pay much attention to it during Windows 10 period. So, but Windows 11, I think, has been developed to support things like passkeys. So when you register on a site that supports passkeys, Windows generates a public and private key pair. The private key is stored locally, and it's probably stored in your trusted platform module, or TPM. And in my way of thinking, this may be one of the basic reasons for Windows 11. I don't have that on any authority, but it looks like the timing and the reasoning. Anyway, so the public key is sent to the site and it's linked to your account, but you have the private key stored in your Trusted Platform Module, or TPM. So you can think of the TPM as a vault inside your computer. That vault stores, it does a lot of things. It stores cryptographic keys and passwords in a tamper-resistant environment. It works with the operating system's secure boot to ensure your system hasn't been tampered with before startup. And I have to admit, I don't know a whole lot about secure boot, but I think it's a good idea. And it securely stores keys used to encrypt your hard drive if you encrypt your hard drive. I don't usually recommend that because if you lose that key, you're really in deep trouble. And it helps with authenticating biometric logins like facial recognition and fingerprints. And Windows Hello. So it's got a future, and I think it's one of the main reasons for going to Windows 11. But that's, again, I haven't got that on any great authority. So in Windows 11, you can go to Settings, Accounts, and Passkeys to see what passkeys you've set up. You see all the saved passkeys. And when I looked on my computer, I had 0 passkeys found because I hadn't been using them at the time. And in fact, I don't have any passkeys myself right now. But I think you're going to see them in the very near future. And passkeys are being implemented on our phones. Android supports passkeys starting from Android 9.0 with full integration via the Credential Manager API. That's 9.0. The latest Android is 16. So they planned ahead for that quite a while ago. And Apple introduced passkeys in iOS 16, and they're now into iOS 17. So they have it tightly integrated with iCloud keychain and the secure enclave. And if you have an iPhone, you know what that means. So there are lots of companies suggesting the use of iPhones, or at least it's giving you the option of using passkeys. Microsoft is, PayPal, I've seen ads for it, and Ring, they're setting up passkeys. So I think you're going to see a lot more of passkeys in the future. So Apple uses passkeys to enable more secure and convenient sign-ins to apps and websites, replacing traditional passwords. And they say passkeys are digital credentials stored on your Apple devices and synchronized across your devices via iCloud keychain. They're resistant to phishing. They're uniquely generated for each account, and they leverage biometric authentication for added security. So this is Apple's version of this presentation in a nutshell. I think they're definitely behind it. So soon we all may be using passkeys. We'll see. And that about brings me to the end of that presentation. And I'd like to answer any questions if I can.
Any questions, anybody?
Turn it back to you, Jim.
On the passkeys, on the Apple passkeys, they're now putting it on all their upgrades. They're putting that passkey, and you have to use a passkey to get into anything on the Apple phone, but you can disconnect it. I disconnected mine. because it was driving me nuts.
What, did you have the option of passkey or password?
Mm, I didn't put in any, I used password to get into my Apple account, but not to get into my phone and get into all the apps on my phone. That passkey, the upgrade from Apple, the recent upgrade, was just making you do it. And I told him I did not want that because it was, you had to enter that passkey and it was annoying. Every time you are opening the phone to do anything, or every time you are getting into photos, you had to open it. You had to do it with a password. You couldn't make a phone call. You couldn't do a text. You couldn't answer a phone call without putting in that pass key every time.
Right. Well, we're just not used to passkeys, and I think they're trying to nudge you in that direction. You know, when you use the passkey, you're actually you're actually using it for authentication into the server, not into your phone.
Hmm.
So it would be the server. So, but of course, Photos is the Photos server that you'd be using. So I could see using passkeys on Photos, but it's getting access to the Photos server, not so much to the app on your phone.
Okay. I just know they started to do it and they try to each time lock you out, but you can deactivate it, and I had them deactivate mine.
Yeah. Yeah. Well, I think like I said, I think that they're trying to nudge you in that direction, and that's just the way things are going to probably go.
Right.
Bill, can I ask a question?
Sure.
It makes me crazy, the passkey thing, because it seems to be obviously honed into just you. And like if my spouse wants to get into YouTube TV or something, if he doesn't have my iPhone, he can't log in. And
Yeah, that's right. Yeah.
it bothers me. I mean, there's got to be some kind of a fix or a remedy for
Well,
that.
I think Apple realizes the problem, and they advertise that they can use passkeys across many devices. I don't have an Apple phone, so I can't tell you for sure, but they do advertise that they will handle multiple devices. I'm not sure how Android does it, and I have an Android phone myself.
Mhm.
So yes, that's a problem. Multiple devices is a problem. With passwords, you just tell a person the password and you're in business. But with passkeys, they're more secure, and that's the idea.
I agree. And I will say my bank even now does, I have to authenticate through my telephone to get onto my Mac.
They
With
use the
photo.
two-factor authentication.
Yeah,
Right. Yeah. Yeah, you definitely want to have it with your bank or any financial institution.
thanks,
It,
Phil.
okay, thanks.
I have a question. This is Marcia. So
Hi.
somehow I missed, what does the pass key look like? Dee said she had to enter it every time she went anywhere. What?
No, the actual pass key is just a file of a text file of a long sequence of text characters, which look like just random, but they were created when your pass key was set up. And it's all done automatically. So you never really come in contact with the file, the text
So
file.
how did Dee enter it to get into her photos?
How does what?
Well, Dee said she had to enter it to get into her photos.
Well, you
Well,
have to create it.
you,
It would not let you, Apple, the new updates on Apple, they all come with it now. And it would not let you not do it. So you either have to make a pass key number, and you have to use that. I just learned from Apple just the past few weeks that that is that will come now on every upgrade from Apple. And the only way to not use a passkey is deactivating it. And you have to go get into your, they had me go into the iPhone thing and get to where they have password and passkeys in there, maybe we could ask someone to give us a course, I mean, a presentation on it, but it's in there and it has the password and the passkeys. And
Yeah.
right in there, you can deactivate that passkey, and then you don't have to put one in to use it because it'll drive you crazy. Oh, I'm telling you, it was taking up so much time I asked them how. I only use my phone, my cell phone. I said, how would I call by the time if I have an emergency, I have to call 911 and I forget what that darn passkey was. How can I use my phone? You couldn't.
Well,
Phil, I think Marcia's question was, how does one activate or make their passkey known when they're asked for it, or how does the system see it? You're saying it's a long text file of some sort. Well, they don't type that in. How does it get to the phone or the computer?
when you try to go to a server, you use an app to get to that server. That app has been set up for passkeys. It will just ask you for the passkey. There's nothing that you have to put in. You have to just say you want to use the passkey because there's only one passkey per server for you.
So it's just pushing a yes button?
Yes, yeah.
Well, can you give us an example of it? I'm looking at on my phone, I have passkey. It says passwords. And when I click it open, it said passkeys 0. So I don't have a passkeys on it now because I deactivated it.
Right. So if you go in and select the passkeys as opposed to password, that passkey should be shown in your in your user account.
Okay.
But you never have to get into that. The app that you're using to go to the server will just ask you if it's set up for passkeys, it will just ask you to authenticate, and you'll just click a button. It should actually be easier access, or at least as easy as it is with a password, only you won't have to type anything in. You'll just have to click one start button.
Okay.
That's how it sounds like it should work. We would have to have an example. Try one of the, you'd have to try one as an example. And with an iPhone, it should actually be easier because Apple is really behind this. Maybe Bill Crow in one of his iPhone classes could show it.
That would be nice.
And what happens when you go to your Windows computer?
In my Windows computer, I just have my password. I get into that with. Get into the computer. It's the password. It's not the passkey. But this iPhone.
Let's say you set up a passkey with your bank.
Yeah, this is the problem with that they haven't really made obvious. When you go to multiple devices, how do you use multiple devices with that same pass key? Because as I had said, when the pass key is set up, the private key is stored, and it's stored in a protected area. So if it's stored on your phone, how do you make access to that on your computer? I certainly don't know the answer to that. And the best source of that would be whoever is setting up whoever you're using to set up a passkey. Like if you went to PayPal and set up a passkey, you could ask them, how do I use this now on my home computer if I set it up with my phone, or vice versa? I don't know the answer to that.
The authenticators have solved it in a way because they send the request always to your phone. You sign on to Schwab or something, and then they send a request to your phone that says, please enter your semantic code. And there's a code generator on your phone. But the passkeys eliminate that extra step.
It should. That's the intent.
Yeah, and that's why they have a problem.
Right. Yeah. I don't know the solution to that, and hopefully we'll see that as time goes by. Maybe this is one of the things that have kept it from being more accepted if they've been talking about this for almost 10 years, over 10 years. So some questions may not be able.
I think I'll call Apple and now that I learned more what passkey and password is and ask them.
Yeah, good. Let us know what you find.
Well, the question for Apple is if I create it on my iPad, how do I access the application from my iPhone?
Yeah, I think they've solved that problem. They should be able to give you an answer. Apple.
The answer is they don't store it on the device. They store it in their cloud.
Right.
And that's not the same security.
That may be the way they solve the problem. Yes, they have the, what did they call it? iCloud, the iCloud
Right.
keychain. So that's
Yeah.
probably is exactly right. You're
Right.
probably exactly right. It's the keychain in the cloud. That's what allows them to use it on all of your devices. Now, is that bad?
It's not as secure.
It doesn't sound as secure as it should be.
Are there any other questions for Phil?
I just have one thing to add briefly. I don't know about the Apple ecosystem, but let's say you have Windows 11 and you have two computers. You log into both computers using the same Microsoft account. If you are using the Microsoft Edge, this is the key, and this is where it becomes cumbersome. Microsoft Windows only supports the Edge web browser for synchronizing passkeys. So if you use Microsoft Edge on computer one and you set up a passkey, it will link into your Microsoft account through Edge. And then when you go to your other computer and use Edge with the same login account, it'll know the passkey. The problem is it doesn't work with Chrome or Firefox.
Right.
It only works with Edge.
Yep.
How many people use Edge? Raise your hands. Right.
Sometimes those browsers are brought in automatically and you don't even know you're on it.
Yeah, if it's a default.
Yeah, that's true.
Now, here's what I do. Here's how I solve the problem. I have a password manager that supports passkeys. And in Windows, when Google or Amazon said, would you like to set up a passkey? I stored that passkey in my password manager rather than in Windows. And so my password manager is the same on both computers. And that's how I use passkeys on the computers.
Pretty smart.
Yeah. Good solution.
Good thoughts.
Hopefully they'll solve these problems in the near future, and we won't have to use alternate solutions.
But it is a bit of a mess right now because each vendor wants to control everything.
Hey, any
Yeah.
other questions? Okay, I would, boy, for 8 o'clock, Bill, you timed it to the second. Very good.
Perfect. Great.
I'm thankful for your presentation. I've heard a lot about passkeys years ago, and I wondered what the status was now. And it seems that there are the same issues that keep coming up. So thank you for your presentation. We can know what a passkey is a little bit different than a password, so we can be a little bit better prepared when these times come and our apps start hitting us with requests for passkeys. So thank you, Phil. Let's give him a hand or a wave. And thank you for your time, Phil. Really appreciate it.
Glad I could help.